Hello there, my name is Ascard. In this course, we are going to be talking about C++ programming language. C++ programming language had been originally developed at AT&T Bell Labs many years ago. It has been developed by Bjorn Strustrup and many others. Originally, it was created for embedded systems that are resource intensive, but these days C++ is used in many different uh, applications and many different scenarios out there. C++ is syntactically similar to C and Java. The difference between Java is multi-platform. Java compiles to bytecode, and you can run the Java bytecode anywhere where you have the Java virtual machine. C++ compiles to native code, so it's a little bit faster. You can run in multiple machines. If you have the common common language runtime (CLR) running on those machines. So it is possible to have the multi-platform capability with Java, provided you have the CLR out there. C++ has many rich features. It has threading. It is object-oriented programming language. It has many advanced features like templates and other things. Uh, One of the complaints of C++ is that if it's a very complex feature, some of the interactions are quite hard to understand and could be quite daunting out there. But we use it as a pedagogical tool. It's good to know all the concepts in a teaching environment, and we used only the simple features of C++ to make sure we have minimum interactions with other things. So we minimize the factors that make it more complicated out there. Now, as I mentioned, C++ is an object-oriented programming language, so we'll talk about object-oriented programming before we go into the syntax of C++ itself. Object-oriented programming has some concepts like data abstraction. Data abstraction basically means that if you have property, attributes, and data interfaces, there's a clear separation between these and the implementation details out there. So we create interfaces for in data abstraction, and we decouple it such that the interfaces are separate from the implementation of the object itself. It makes life easier, it's easier to use, it's easier to maintain, and it's easier to, if you make any changes to the implementation, it has less breakage out there. So you should know about this useful thing called data abstraction. The next thing that is important is encapsulation. Encapsulation basically means that we hide the implementation details from from the object that does not need to know the implementation details itself. This way, we also minimize breakage because things are hidden from the user and it's not complicated out there. And C++ has the concept of classes, which has access qualifiers like private, public, protected, and this sort of hides the implementation details from the user. For example, if you have a private property or private member function, it's not accessible by anybody except for this class itself. If you have a public member function or property, it's going to be accessible by this class or any other class that needs to access it. So this way, object-oriented encapsulation is built into C++, and we use it quite frequently to do many different things. The next concept that is very important is inheritance. Inheritance basically allows the parent or ancestor to to have its child inherit some of the properties. This allows for code reusability. So if we have member functions that have been defined in the parent class or the ancestor class, we do not need to code them again. Instead, we have a has a relationship or is implemented in terms of relationship, and we derive all the properties and member functions from there. So it's less coding and it's easier to maintain if you have that kind of relationship out there. So the next concept that is very important in C++ is polymorphism. Typically, if you have a hierarchy of classes where you have base classes and derived classes, and if your pointer points to one of the derived classes and you have declared it virtual, then the member functions of that class is going to be called. So if you have a pointer that is pointing to derived class B, it will call the member functions of derived class B. If you have a pointer that points to derived class A, then it will call the member functions of that class. This is typically called dynamic binding in C++. It may be called other things in other programming languages, but it basically means you can uh, transform or change into many different objects based on where you're pointing to, and based on your pointer, the code gets called. So it gets dynamically called. It's not statically linked, but rather dynamically determined, which member function is going to be called. So it's a very important concept, but it's also very complicated if you have multiple inheritances and you have virtual destructors. You have to make sure that wherever you have virtual, you have virtual destructors in your derived classes. Otherwise, the interactions may not be well defined, and you may have some aberrant behavior out there. So, but we'll be using some of the simpler features of C++ to make sure that we understand the concept and we use it quite efficiently. And object-oriented programming is typically done to make sure we have clear interfaces and we have code that is easier to understand. One of the drawbacks of object or dynamic binding or polymorphism is that it's hard to read the program execution flow. You cannot really tell, you cannot go by sequence that it's going to be called because it's based on a pointer that your code is going to be called. It's not statically linked, but dynamically linked. So it makes life easier. But the advantages sort of negate the drawbacks. The advantage of clear and clean interfaces, minimal software change, leads to the choice of object-oriented programming language like Java and C++ in many applications out there. So you should remember those important points. Now, in C++, we have the concept of classes. Classes typically in objects, and you can have member functions that are defined in classes, and property or values can be also defined down there. Certain properties, member functions can be public, private, or protected. If it's public, it's accessible by the entire class in the world. If it's private, it's only be accessed by the class itself, or if it's protected, that it can only be accessed by the class derived classes of this parent out there. So we have the object-oriented concepts built into C++, so it makes it a natural selection for programming C++ languages. We you use the CRC cards in object-oriented programming design to determine what objects we have. We first determine what are the major objects. Then we have our index cards to define what properties it has, what attributes it has, what member functions or interfaces it has, and then how does it relate to the other classes itself. Its relationship is also delineated in this type of CRC card design. So many people use that, and you may typically find whatever technique you use, you will find that object-oriented paradigm is easier to understand, easier to maintain, and it has clear, clean and clear interfaces that makes it easier to program, and that's why it is a natural choice for programmers out there. In this installment, we are not going to be talking about C++ syntax like pointers, templates, struct unions, arrays, and many other things, but only we'll only talk about the object-oriented concept. That's it. That's all we have for this installment. Thank you very much.